Today we are going to discuss on GraphQL. What is GraphQL? Why it is needed? Then we'll compare GraphQL with REST. And then we'll see a live example by creating a server in Node.js and then consuming that localhost service in Swift Playground. So let's begin. So what is GraphQL? Before we go into GraphQL, let's understand what is graph. A graph is a representation of a network and it describes the relationship between lines and points. And that's how it looks. If you see here, book, author, publisher, and location, they all are entities and somehow they are connected with each other. So either we can have separate services for them for extracting the data, or we can have one single service. So in a nutshell, GraphQL is a replacement for REST. It is not only a replacement, but GraphQL can also use REST services. The GraphQL can use the DB, it can use the existing microservices, and similarly it can use the existing REST as well, or it can act as a replacement for REST. It's a query language, it's a pattern. GraphQL was created by Facebook in 2012, then outsourced in July 2015. And finally, a new GraphQL Foundation was established in 2018, November 7th. Lee Bryan is the executive director. You can get the specifications at this link. So GraphQL is designed for developers of web mobile apps, HTTP clients, to be able to make API calls to fetch exactly the data they need from their backend APIs. So let's see what a typical REST API looks like. In this you can see that we are using a GET service wherein I'm trying to get the data for products with ID 123. It will return me all the data which is related to 123 from the DB or a service. Now let's see what's the GraphQL approach here. I will still have an endpoint which is get/GraphQL, but instead of hitting the ID, I will hit the query. In this query, I'll tell that what all fields I need, and I get back only those fields. Even though there might be hundreds of fields in DB or in the service where I'm hitting this, but I'll get back only those data which I need. So this is one difference. Let's see one more example. We have here 4 services: add employee, get employee, update employee, delete employee. And we have separate services for this and separate endpoints. You can see here, employee with ID, get, put, delete. Let's see the GraphQL approach here. So instead of having 4 endpoints, GraphQL always have a single endpoint, and the rest of the things are done by the query. You can add the employee, you can get the employee, update and delete. Get is a simple query, which is called as query in GraphQL. And add, update and delete can be done through mutations. These 3 crude operations, add, update and delete, is done through a keyword called mutations in GraphQL. Let's see one more example. Say for example you have database in different zones in US, like database in US West, database in US East, database in Europe Central. So you have different geographical locations as well. And you can see that they report to a REST API servers in US Central, here also US Central and US Central. What's the GraphQL approach here? So all of these centers can report to one common US Central server, which is the GraphQL server. And it will be just one endpoint for all the platforms, no matter which location they are hitting. There will always be one endpoint, and the developer can decide which field he can fetch Basically, we are making the REST APIs more smarter for developers. Let's move ahead. What are the common issues with REST? Overfetching. When a service is being served in multiple platforms, there might be a situation that the one platform doesn't require a few fields which is being served to the other platform. And consider apps like Facebook, Twitter, LinkedIn, or many other apps which are supplying millions of data per minute. For them, if even 10 fields are coming extra every minute, and it's 10 multiplied by 1 million. Underfetching. There might be a situation that one platform requires some data, but it is not there, as that service has been serving the other platform with specific set of data, and that's underfetching. API changes and evolution. With REST, you always have to maintain the versioning, the deprecation of the REST APIs. This is not the case with GraphQL. It's a one single endpoint. Graphs. So this is the actual graph which is taken from the Microsoft website. You can see here various nodes like teams, groups, meetings, messages. Each of these nodes has its own interconnected graphs inside them. Now think, for example, these many services in one node. How about if all these services are streamlined into one single service, and then developer decides what data he needs? Don't you think how smart that API becomes? That is what GraphQL is all about, in a nutshell. So GraphQL benefits: faster, hides complexity, no over and under fetching, a radical structure, strongly typed. You have to define the type, otherwise it won't work. Versioning not required. Now, since we have discussed about the GraphQL and its difference with the REST and where we can use it, let's see where it fits in the service level architecture of any organization at a base level. So you can see this is the front end, this is the back end. So you need to install GraphQL SDK 1 at the client end and the GraphQL SDK for the backend as well. Installing the GraphQL at client end is optional. You can use the post query to send the query in the body, but at the server side you have to integrate it with the GraphQL endpoint. And once you integrate, you can see that it has types, queries, mutations. Mutations, I told you, it's for CRUD operations. The add, update, and delete. Okay, then we have resolvers here. So what resolvers does is they map the data with the schema. Whatever data is coming from the back, it maps it to the schema which the developers have made. So let's look this base level into a simple small example I made in Node.js and Swift.